Hello there. In this video we will check the validity of logical argument. The first one, if a person stays up late tonight, then he or she will be dull tomorrow. If he or she does not stay up late tonight, then he or she will feel that life is not worth living. Therefore, either the person will be dull tomorrow or will feel that life is not worth living, it says. Therefore, first of all, how many unique statements we do have? Person stays up late tonight. We can represent by letter P. Stays up late tonight. We can represent by letter P. The second part, this one is, we can say P, will be dull tomorrow. We can say it Q. Okay, the third one, feel that life is not worth living. We can say it R. Okay, therefore now let us construct the arguments. It says, if a person stays up late tonight, that means P implies, then he or she will be dull tomorrow. That's Q. First premise. The second one, if he or she does not stay up late tonight, that means negation P implies, then he or she will feel that life is not worth living, which is R. Therefore comes, that is the conclusion part after this. Therefore, either the person will be dull tomorrow, that is Q, or will feel that life is not worth living, that is R. Therefore, how to check the validity? Remember, premises are true always. This is true, premise. This is also true, premise. But don't forget, P implies Q is the same as negation P or Q. And negation P implies R. Negation P implies R is the same as P or R. Just negate the first one and the implication change into OR, and the second will come as it is. So try to observe these two now. Negation P or Q and P or R. The conclusion, remember, Q or R. To say this is valid, it's enough to know the truth values of Q or R. If Q true enough, the whole thing will be true, or if R true, the whole thing will be true. But Q is combined by OR here. R is combined with P by OR. Both of them are combined by OR by disjunction. But here R is combined with P and Q is combined with negation P. So that if P true, what will happen? If P false, what will happen? Let us see. Both cases. We do have two cases now. If P true here, that means necessarily negation P will be false. Let us try to indicate negation P will be false here. Okay, let's write it again once here. When you try to make it visible, the first premise, this one, is the same as negation P or Q. The second premise, this part, is the same as P or Q. Now we are trying to see the cases, because the two premises, they contain P and negation P. Now, if P true, remember, if P true, that means negation P will be false here. So Q necessarily will be true, so that's enough to be true. It will be valid in case of P true. What about P false? If P false, this is going to be false. I mean, this one R, sorry, this one is R. So if P false, necessarily R must be, because as a premise, the whole thing, this one true. So to make it true, if P false, R must be true. So if R true again, it's going to be valid. So when P true, Q will be true, because negation P will be false. As a premise, the whole thing, this one is true. Therefore, the case, imagine, if P true, Q will be true. That's enough condition. If P false, R will be true. That's enough condition. So in both cases, the conclusion part will be true. That means in either case, either of the two will be true, because Q and R are combined with P, one with the P, the other one with the opposite of P. So the P will be the deciding factor for the truth value of Q and R. But P cannot have more than two truth values. If P true, then the Q will be true at the same time. Therefore, it will be valid at that time. When P false, the truth value of R will be true, and then still it will be valid. Therefore, this logical argument is valid. Let us see the next question. The next one, if rain comes, or if rain doesn't come, then the crops are ruined and the people will starve. The crops are not ruined, or the people will not starve. Therefore, the rain comes, it says. First of all, P, rain comes, we can say. And R, crops are ruined. I mean, we can say this one Q, it's okay. Most commonly, PQ will be used, and people starve also are. Okay, now let us construct. If the rain doesn't come, that means negation P implies, then the crops are ruined and the people will starve. That means Q or R. We do have this one premise. Second premise, the crops are not ruined. That means negation Q, or the people will not starve, or the people, that is negation R. We do have this. Finally, the conclusion, rain comes, which is P. Therefore, what are the premises? Premises are here. 1, 2, which is both of them are true. Don't forget. But the second premise, we can rearrange. We can extract the negative from both. When you take out the negative or the negation, Q and R, obviously it is true. So this one true means necessarily Q and R will be false. What did I do? I take out the negation. When you take out the negation, the or will be changed into and by De Morgan's rule. Therefore, negation of Q and R, it is the same as the premise what is given. The second premise, negation Q or negation R, is the same as negation of Q and R. They are the same. So since it is a premise, it is true already. But if I remove the negation, it will be false. That means the negation of something, if it is true, that means that something obviously at the beginning it was false. Therefore, I can bring this false case here, because here the conclusion part of the conditional statement, that is negation P implies Q or R, it is true. But here Q or R is already false. We got it from the previous one. Actually, it is not Q or R, it is Q and R. Look the statement here. First statement, if the rain doesn't come, then the crops are ruined and the people will starve. It. So this must be N. So I brought it from there. Therefore, if this is false, the premise must be what? To make the whole premise true. Okay? This is a conditional statement implication. In case of implication, if the if part, if the conclusion is false, necessarily the if part or the premise has to be false to make it true. So what do you know? Negation of P becomes false. Negation P, false. What does that mean? P is true. This is what we were looking for. P become true means it is valid, obvious. The next one, if the team is late, then it cannot play the game. So P, team late, and Q, play a game, can play a game. Shortly, and R, refer here. Therefore, if the team is late, that means P implies, then it cannot play game, negation Q. If the referee is here, that means R implies, then the team can play the game, that's Q. Then the team is late, which is P. Finally, the conclusion comes. The conclusion, therefore, the referee is not here, that is negation R. Now let us see step by step. Premise, which is true, premise, true, premise, true. At the definition, in case of logical argument, consider all the premise as true. Now, P true means, let us start from here, first step. P true means I'll bring it through here. So the whole to be true, what must be negation Q? It must be false. Therefore, I'll write here it must be true here. Otherwise, true implies true will give you true only. True implies false, it will give you false, but as a premise, the whole thing is true. So necessarily negation Q true. If negation Q true, the next step, Q must be false. Because negation Q and Q, they are opposite. So negation Q is true implies, what does that mean? Q must be false. Again, this is the middle premise, it is true. So to be true, what must be the truth values of R? It must be false. Because false implies false will give you true. Otherwise, if I make it true, if I take R as true, it will be false. But as a premise, it's already true. Therefore, R must be false. The negation of this false will be the conclusion, which is true. Because negation of false will be true, that is still valid. The last question for today, it says, if mathematics is a good subject, then it is worth learning. Either the grading system is not fair or mathematics is not worth learning. But the grading system is fair. Therefore, mathematics is not a good subject, it says. Now let us decompose. We have three statements here. They are combined. The first one, math is a good subject. I just allocate by P. And the second one, it is worth learning, Q. And finally, grading system is fair, that's R. Now let us combine. If mathematics is good subject, that is P implies, because if part is only if part, then it is worth learning, that is P implies Q. That is first premise, obviously it is true. Second premise, either the grading system is not fair, that is negation R, because grading system is fair is R already, negation R, or mathematics is not worth learning, that's negation Q. Worth learning is Q. Second premise, again it is true. The third one, but the grading system is fair, which is R. Again it is true. Finally, the conclusion, therefore, mathematics is not a good subject. Sadly, we may get some kind of valid result and mathematics is not a good subject will be valid, which is not fair, but let us see it. So as a premise, we have to start from the single one. As a premise, R true. Then negation R will be false. Don't forget, because as a premise here, true. And then if negation R, for obviously by a rule of negation, if R true, negation R will be false. But this whole thing is true, and the connector here, it is OR. So either of the two must be true to be true. So that means negation of Q necessarily will be true. If negation Q true, I will bring it here. The Q will be false, obviously, because opposite of true. So if Q is false, necessarily P must be false. The reason, only false implies false will give you true. Otherwise, if it is true, true implies false will be false. But as a premise, P implies Q is true. Therefore, we know the truth values of P, which is false. Then if P false, what will be the opposite or the negation of P? That is true. So this one, the conclusion part is true. Therefore, this logical argument is valid. But the conclusion, it is somehow not fair. But this is the way how we can practice given logical arguments, statement-wise. If it's given, we can construct logical arguments and then we can prove the validity of those arguments. Thank Thank you for watching.